Hello everyone. In this video we will be talking about kinetic and potential energy. Kinetic energy is the energy contained by moving objects. So for example, if a car is moving at 10 meters per second, it has kinetic energy. We can find kinetic energy of an object using this formula of 1/2 times the mass times the velocity of the object squared. Potential energy comes in many different types. We're considering two main types of potential energy. We consider gravity and spring. Let's say we have a ball that's standing on the ground and we put a ball on the shelf. Say if the ball were to roll off the shelf, when it falls, it will have kinetic energy. But where does it gain its kinetic energy? It gains it from gravity. As the ball falls, gravity accelerates the ball, giving it a velocity, hence giving it an acceleration. So when we displace the ball from its initial height of 0 to a height of 5 meters on a shelf, we give the ball a potential to gain kinetic energy. This potential energy that we give the ball is referred to as the potential energy, and in this scenario, it is the potential energy due to gravity. Potential energy due to gravity we calculate using mass times the acceleration due to gravity times the height of displacement. Now, this height does not necessarily have to be in reference to the ground. Let's say if we had it on a shelf 5 meters above the ground and we move it to a shelf that is 10 meters above the ground. The change in potential energy is the difference in energy from the 5 meter height to the 10 meter height. Another important type of potential energy that we will consider is the potential energy due to spring. When we compress or expand a spring, we cause it to store energy. And when we release the spring attempts to regain its equilibrium length. This is the length of the spring when it is at rest and it is not compressed or expanded. This length we reference as the 0x. We can find the potential energy stored in a spring using 1/2 times the spring constant times x squared. X here is the displacement of the spring from its initial position, or initial equilibrium length. This equilibrium length we refer to as x equals 0, where the spring is completely relaxed. We can compress the spring or expand the spring. Both of these actions will give the spring potential energy, which we can find using this formula. One thing to keep in mind is for a change in potential energy or kinetic energy, we must do work. For example, when we raise the ball from its initial height to its next height, we had to do work on the ball to cause a displacement. We had to exert a force on the ball and we caused a displacement of some length. Similarly, when we have kinetic energy, if we want to slow the car from its 10 meters per second speed to 0, we must apply friction, a force, which causes some displacement or a length that the car will take before it stops. Hence, we did work on the car to change kinetic energy into work. So, what would be the work required to get the kinetic energy to go to 0, or to have the car go to a stop? That would just be equal to the kinetic energy of the car at 10 meters per second. So the work done would just be equal to the kinetic energy, which is 1/2 times, let's consider a 1,000 kilogram car, times the velocity squared, which gives us an energy of 50,000 joules is required to stop the car. This energy can convert from potential energy to kinetic energy, as we see when the ball rolls off the shelf. When we let a ball or any object go from a height above the ground, we'll see that gravity will pull the object to the ground. So, what would be the velocity of a ball that is 5 meters high on a shelf when it falls to the ground? We can use kinetic energy and potential energy to figure this out. So, in this scenario, we know that all the potential energy will go into kinetic energy when the ball reaches the ground. So we know the kinetic energy equals the potential energy. So we have 1/2 times mv squared equal m times g times h. So the velocity of the ball when it reaches the ground will be 2 times 9.8 times 5 square rooted. And once we do this calculation, we get that the velocity of the ball at the ground will be 9.89 meters per second. These formulas and these different types of energies are very important to keep in mind as you continue for the next sections when we consider the conservation of energy. Thank you for watching and see you for the next video. I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what physics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you're a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website at www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.